In this video, we're going to talk about the sine law and the cosine law. When using the sine law and the cosine law in triangles, we need to remember that angles are denoted by capital letters and side lengths are denoted by small letters. The cosine law reads c squared equals a squared plus b squared minus 2ab cos c. And the sine law reads that a over the sine of a equals b over the sine of b equals c over the sine of c. Or if you prefer, sine a over a equals sine b over b equals sine c over c. So sometimes we're given a situation of side angle side. And what that means is we have a triangle, and we know the values of a couple of the side lengths, and we also know the value of the angle in between those side lengths. When that's the case, we're going to use the cosine law to determine the third side. So for instance, the question given here, we draw a triangle D, E, and F, and we see that side length E is always across from angle E, and side length D is always across from angle D. And so we know both of those side lengths, and we know the angle in between them. So we use the cosine law. We say F squared equals D squared plus E squared minus 2DE cos F. And we simply sub in the values. Okay. And what we end up with is an approximate value for F squared of 259.86. A lot of people just leave that value in the calculator and then hit square root, and they get that the value of F is approximately 16.1 centimeters. Well, sometimes we're given a side-side-side situation, and in that case, we want to use the cosine law to determine the magnitude of one of the angles. If this is a case where we're solving for the whole triangle, we'll find the largest angle first, because which will be opposite the largest side. We do that because it eliminates the possibility of an ambiguous case of the sine law, which is an issue we'll talk about later. For now, though, we're not quite at the point where we're solving the entire triangle. This question specifically says, evaluate angle H given the three side lengths in the triangle GHI. So we draw the triangle GHI, and we draw the side lengths down, and again, side length G is opposite angle G, side length H is opposite angle H, and side length I is opposite angle I. And we can say H squared equals G squared plus I squared minus 2GI cos H. Again, we're looking for the value of H, so we'll do our best to isolate cos H. We see that we can put in the values, and we have our first line here. We're going to subtract 28.6 quantity squared and 42.1 quantity squared from both sides, and we have the equation you see here. And now we can simply divide both sides by negative 2 times 28.6 times 42.1. And when we do that, we have a value for cosine of H. And we hit the cos inverse button, and we see H is approximately 64.7 degrees. Now, another situation we can come up with is angle side. In this case, we have two angles, and we also know one of the side lengths. Well, something you might realize pretty quickly is if you know two angles of a triangle, it's really easy to find the third angle, because you can just keep in mind that the three angles added together must equal 180 degrees. So we can draw the triangle as given. And if we wanted to, we can, like I said, use that 180 rule. It's pretty quick, and it lets us know right away that angle M is 62 degrees. Now, we have to actually, in this case, find angle M, because they're specifically asking us, in this case, for side length M. Had they been asking us for side length P over here, had they been asking us for that side length, we wouldn't have had to find out what angle M is. But they're asking us for side length M, and so we need to find out what angle M is to use the sine law. So we can say M, which is in red, the side length, which is unknown, divided by the sine of M will equal N divided by the sine of N. So M over the sine of 62 degrees equals 12.9 over the sine of 77 degrees. Multiplying each side by the sine of 62 degrees, we get M is roughly equal to 11.7. So M is roughly equal to 11.7 centimeters. Now, that leads us, we've now seen a case in this slideshow where we've found an angle using the cosine law, and we found a side length using the sine law, and we also found a side length using the cosine law. The one case that we haven't yet talked about is what to do if we need to find an angle and we need to use the sine law. So sometimes we're given a side-side angle situation. So we know two sides of a triangle and one angle, and the angle we know is not the angle in between the two sides that we know. When that happens, we have to consider the possibility that we could have 0, 1, or 2 solutions. So you might wonder, well, why would there be two correct answers when using the sine law to evaluate an angle, but only one correct answer when using the cos law to evaluate an angle? And the answer lies within the unit circle. Suppose I told you that the sine of theta is equal to 0.5. Well, if I told you this, then you would draw yourself a unit circle and you would tell me, well, theta might equal either theta might equal either 30 degrees or 150 degrees. Well, both of those angles are possible within a triangle because a triangle has 180 degrees total. So it is actually possible to have a 150 degree angle. In other words, it's a possibility that there are two answers. But if cos theta equals 0.5, well, then we see that our two answers using the unit circle approach are either 60 degrees or 300 degrees. There's no way a 300 degree angle could possibly be in a triangle. So we know that second answer will never be true. So that's why when using the sine law to find an angle, we have to consider the possibility there could be two answers. But using the cos law to find an angle, we know that there will only be one. Okay? And that's what is written on the screen in front of you right now. So let's say we have a side-side angle situation. We'll give you a scenario where that happens, and there are actually 0 solutions. Suppose we are given triangle ABC, and side length A is 16.1 centimeters, angle A is 79.2 degrees, and side length C is 19.5 centimeters. Well, if that was to happen, we would see that our only option is to use the sine law to find out what angle C is. We cannot use the cos law, and we cannot use the sine law to find a side. We're stuck. We only have one option available to us. Use the sine law to find the magnitude of angle C. So we set it up, sine C over side length C equals sine A over side length A. So sine C over 19.5 equals the sine of 79.2 degrees over 16.1. We multiply both sides by 19.5, and this expression right here is roughly equal to 1.1897. Well, if we try to determine the sine inverse of 1.1897, we see that it doesn't exist. In other words, there's no triangle possible. There is no solution. Now, we'll sometimes get a case where we have a side-side angle situation, but we have one solution, but not two solutions. So suppose, given the situation in front of us, we're asked to find the magnitude of angle U. So we set up the diagram as shown, and we see we have two side lengths, and we know one angle, but it's not the angle that's in between the two side lengths. Well, we set it up. We see that the sine of u over u equals the sine of t over t. So the sine of u over 48.3 equals the sine of 59 degrees over 51.7. Multiplying both sides by 48.3, we see the sine of u equals 48.3 times the sine of 59 degrees over 51.7. And so sine of u equals approximately, there should be an approximately symbol there, 0.8008. So again, there should be an approximately symbol there. And when we determine the sine inverse of that using a calculator, we get 53.2 degrees. All right, so we see intuitively that we could put a 53.2 degree angle in for u with no problem whatsoever. It'd be no problem to fit a 53.2 degree angle in there and simply figure out the magnitude of that third angle. But now let's also consider the second possibility. There's a second angle up here in the second quadrant. 180 degrees minus 53.2 degrees is 126.8 degrees. Well, right away we see 126.8 degrees. If we put that angle right there for u, it couldn't possibly fit in a triangle that also has 59 degrees because we would have used up more than 180 degrees. That would add to 185.8 degrees, and that would be impossible within a triangle because all angles have to add to 180 degrees. So therefore, there'd only be one solution for u, and specifically it would be the situation where angle u is roughly equal to 53.2 degrees. Okay, but now let's talk finally about the situation where we have two solutions. So suppose we want to solve for angle r, and we're given the information shown. We draw our triangle, and what we do is we set up the sine law. We say, okay, well, the sine of r over 41.8 will roughly equal the sine of 54 degrees over 38.4. Multiplying both sides by 41.8, we'll see that the sine of r roughly equals 0.8806. Okay, well, now what we're going to do is use a unit circle approach and see that r might equal roughly 61.7 degrees. And again, it's pretty easy to see a 61.7 degree angle there is totally appropriate looking, leaving us with degrees left over for that third angle q. But what about that second possibility of 118.3? Because we know from our discussions about solving for angles that if sine theta is 0.8806, then theta might be 61.7 degrees, but it also might be 118.3 degrees. Can we put a 118.3 degree angle there for r? And the answer is simply yes, we can. Because 118.3 degrees plus 54 degrees is less than 180 degrees, leaving us with a little bit left over for angle q. It's a possibility. So to determine if 118.3 is a valid answer, we add p equals 54 degrees and r equals 118.7 degrees to see if the sum is less than 180. Q could possibly equal 7.7 degrees, and we would have a valid triangle. So we have to consider both of those possibilities. So to summarize the ambiguous case of the sine law, if we have only two sides and one angle, and if the angle is not in between the two sides, then we must use the sine law to find an angle. If we get an invalid solution, there are no possible solutions. If we get a solution that is less than the angle previously known in the triangle, then there's only one possible solution for the angle. But if we get a solution greater than the angle previously known in the triangle, then there are two possible solutions for the angle, and the second solution will be 180 minus the first one. So let's just show you quickly what we mean by that second point. If we go back a little bit, so what we're saying here is if we get a solution less than the angle previously known, there's only one possible solution. So go back a ways. I'm going backwards on the slideshow now. If we go back to here, you'll see that when we solve for this angle, angle u, we got 53.2 degrees as our first answer using the sine law. That 53.2 degrees is less than 59. That means we're only going to get one answer. But now go to the second one. In the second one, we got a possibility of 61.7 degrees using the sine law to find that angle. And we were in a position where we had to use the sine law to find that angle. We didn't know, we only knew the two sides and one angle, not the one in between the two sides. So when that happened, and when we found ourselves an angle that was bigger than the one we already knew 54, but we found the angle 61.7. That told us we're going to get a second possible answer, 118.3, which was also valid. Okay, so there's different ways people remember those, but that's the gist of it. Now, we talk about solving triangles sometimes. This is an important skill in math. A triangle contains 6 pieces of information, 3 side lengths and 3 angle magnitudes. To solve a triangle means to state the value of all 6 pieces of information. In order to solve a triangle, you must be given at least 3 pieces of information, and at least one of them must be a side length. Now, if you're given a side situation, if you know all 3 sides, then what you want to do is use the cosine law to find the value of the largest angle. In other words, the angle opposite the longest side. We want to find the largest angle first because it's the only one that could be obtuse. Using the cos law to find it provides certainty as to its value and thus eliminates the possibility of the ambiguous case of the sine law coming up later. So try to remember, in a side situation, if you're looking for all 3 angles, find the biggest one first. Once you find the biggest one, you can use the sine law or the cos law to evaluate either of the other 2 angles. And then finally, you have 2 angles, so it's easy to find the third one because you know they all have to add up to 180 degrees. Now, what if you have a side angle side situation and the known angle is in between the 2 sides? So we have a triangle where we know the 2 sides and we know the angle in between them. If that's the case, determine the value of the third side using the cos law. Now, determine the value of either of the 2 remaining angles using the cos law, or if you prefer, you can use the sine law to determine the value of an angle, but make sure that it's not the largest angle in the triangle, because the largest angle in a triangle can be obtuse. So when using the sine law, stick to an angle that you know is acute so that you won't have to worry about that coming up. Okay, so if you're going to have this situation, after you determine the third side, you can use the cos law to be safe to find one of the other 2 angles, or if you prefer to use the sine law, just make sure that you're finding an angle that you know isn't the biggest one in the triangle. In other words, it's opposite one of the sides that you know is not the biggest side. And then finally, just use the 180 degree rule to determine the value of the third angle. Now, you could also have an angle side situation. If you have an angle side situation, determine the either of the remaining sides using the sine law. So what we mean by that is you know an angle and you know an angle and you know one of the sides. So find the third angle. That's really easy to do. And then now that you know all 3 angles, it'll be pretty easy for you to use the sine law to find one of the sides. And then it'll be pretty easy to use the sine law again to find one of the other sides. And like it says in step 3, use the side that you were given in the question to when you find the third side, use the side that you were given in the question as well as the angle that you were given in the question rather than the side you determined in the earlier step, because that'll minimize the potential for rounding error. And finally, you get to the case where you have a side-side angle situation, which brings up the possibility of the ambiguous case of the sine law. And when that happens, use the sine law to determine the value of one of the unknown angles. And you might get no answers, 1 answer, or 2 answers. If you get no answers, you're done. If you get 2 answers, you need to build 2 separate scenarios, 1 for each possible answer. So once you, if you are in a 1 answer or 2 answer scenario, you've got 2 of the angles. Find the value of the third angle using the 180 rule. and then find the value of the third side using the sine law. And if you have a situation where in step 1 you got 2 valid answers, you'll have to do that step 2 and step 3 twice, once for each triangle.